This video is going to cover 4.4, which is solving quadratic inequalities using graphs. Before we get started though, I need you to understand that you have equations here, right? So you can take this equation, this is like y equals. You can plug in any x value you want and get a corresponding y value for it. Let me show you what I mean. So like, for example, I could plug in the coordinate -2, the x value -2. If I did that, I would get -2 plus 4, which is 2. Let me just write it out real quick. This becomes 2 squared minus 8. Do the squared. So 2 squared is 4. Then get 2 times 4 is 8 minus 8. I'd get a y value equal to 0. Why I'm showing you this is because this x input of -2 had an output value of 0, and I can make a coordinate out of that. This is a really handy tool to use. You can plug in any x value and get a y value. So keep that in mind. I'm going to be using that a bunch. Here we go. So you start out by graphing this. Find the vertex. The vertex of this is at -3, -4. Go put a dot there. All right. Now if your a value is 1, you just go up 1 over 1 to get to your next point. But to get to the next point, this, like if it was at -1, I'm going to plug it in. So I'm getting like y equals -1 plus 3 squared minus 4. -1 plus 3 is 2 squared is 4. So this really becomes 4 minus 4, which is 0. So I know -1 has a value of 0 right here. And then it's going to be the same. It's like a mirror image for a quadratic. So this graph looks something like this. All right. Now you have to go and actually answer the question. They're asking, where is it less than 0? That's where is it below the x-axis. So that's all of this section of line. So this red is my answer, but you answer using x values. So that's from -5 to -1. So since it's one continuous piece, I can just write it as -5 is less than x, which is less than -1. Or if I was writing it in as in interval notation, that would be just parentheses -5 comma -1 like this. Okay. The next one is the same graph. So it looks like this. But now they're asking where is it less than or equal to 0. So that's again all of this section. But it also includes these red dots on the end that I put there. So again, it's from -5 to -1, but this time it's -5 less than or equal to x, less than or equal to -1. And it would use brackets for interval form, like that. Okay, this next one is the same graph, -3, -4. So it looks something like that. But now they want where is it greater than 0. That's where it's above the x-axis. So that's this section and this section. So it is from -5 and -1 again, but this time, instead of it being from -5 to -1, it's everything to the left of -5 and everything to the right of -1. So it's like all my x's that are less than -5 or all my x's that are greater than -1. Or as interval form, it would be everything from -infinity to -5 or everything from -1 to positive infinity. You're answering using x values. So you came from negative infinity and you're going to positive infinity, like that. Okay, this next one is the same graph. So here's this line again. And it's greater than again, but this time it's greater than or equal to. So it's again all of these sections, but it's also going to include this red dot and this red dot. So it's from -5 and -1 again, but it's -5 and everything to the left and -1 and everything to the right. So it's all my x's that are less than or equal to -5, or all my x's that are greater than or equal to -1. Or if you wrote it as an interval form, it would be parentheses negative infinity to -5, and that -5 is going to have a bracket, or bracket -1 to positive infinity, like that. Okay, over here. Same thing, you're going to find your vertex. This is at 5, 1. So 5, 1 is here. Now it is negative, so instead of going up, I go down. And it's still like an a value of 1. It's just -1 this time. So you can get away with just putting a dot down 1 over 1 on either side of the vertex. So this is what this graph would look like. They want to know where is it less than or equal to 0. That's below the x-axis. So that's this section, and that's this section right here. Since they used or equal to, it includes these points. So it's everything from 4 this way and everything from 6 this way. So it's everything, all my x's that are less than or equal to 4, or all my x's that are greater than or equal to 6. Or if you were writing it in interval form, you come from negative infinity all the way to 4 with a bracket, or now you go from bracket 6 to positive infinity, like that. Okay, and then this last one. Find your vertex. That is at -4, -8. Put a dot there. -4, -8 is here. Okay, an a value of 2 means I'm going to rise 2, run 1 to my next dot. But now I'm still going to need more coordinates. So this is where I'm really going to use plugging in a value. So y equals 2x plus 4 squared minus 8. If I plug in, I'm looking for where my dot's going to be at -2. So plug in -2 here. So it's going to look like this. All right, -2 plus 4 is 2. Squared is 4. So then times 2, it really becomes 8 minus 8. So it gives me a y value of 0. So I know at an input of -2, I have an output of 0. That's a coordinate right here. And parabolas, quadratics, they mirror each other on either side. So it's right here as well. So my line looks like this. All right, now go answer the question. They want to know where is it less than 0. That's everything under the x-axis. So that's this red section, and it does not include those endpoints. So it's one continuous section from -6 to -2. So I can just write it as -6 is less than x, which is less than -2. Or I can write it in interval form as -6 to -2, like that. So graph your line, figure out what they want, whether they want it greater than or less than 0, and then just answer. You can answer using an inequality or interval form. It does not matter. Hope this video helped.